Welcome to Spring LIB.
So the work needed to stop the train would be equal to the change in kinetic energy of the train. So this would be equal to 1/2 times m times v final squared minus v initial squared. We know that v final squared is going to be equal to 0, which means that the work needed to stop train would simply be equal to negative 1/2 times the mass of the train, so in this case 10 to the 4th kilograms, and then times the initial speed of the train, 20 meters per second, quantity squared, and we find that the work needed to stop is going to be equal to negative 2 times 10 to the 6th joules. Now, the work due to the web is going to be equal to the work of a spring. So this would be simply equal to negative 1/2 kx squared. And this is going to be equal to the work needed to stop. So negative 2 times 10 to the 6th joules. And so when we solve for k, k will simply be equal to 2 times 2.0 times 10 to the 6th joules. And then this will be divided by the stopping distance of 800 meters quantity squared. And this is giving us 6 Newton per meters. So the spring constant of Spider-Man's webs is relatively low. However, this allows it to stretch more and bring it to a stop slowly, because if let's just say that his web had a higher spring constant, that means that it would stop very abruptly, and the passengers inside the train may get hurt. So it is quite beneficial for his webs to have a low spring constant. That is the end of the solution. Thank you for watching.